In question 5.4.12 we work with compound interest. So we're dealing with compound interest there. That's one thing that we know. And we also know some more data that the payment in the initial times or in the present value is 5,000, and then the payment in the fourth period is equal to 9,000. And the question is to find out the interest rate. So we know all the payments, but we want to find out the interest rate. How do we proceed? Well, first step is to actually write down the formula for what we're calculating. We know that the formula for compound interest is the payment at a certain point in time equals to the initial payment times 1 plus our interest rate to the power t, to the power of the periods that we have, because we compound per every period. Okay, so that's one thing. Now let's substitute the data. We know the payment in the fourth period. We know the payment in the initial period, which is equal to 5,000. And then we know 1 plus I to the power of 4. We also know the payment in the fourth period, that is equal to 9,000. So 9,000 equals to 5,000. And here we have 1 plus I to the power of 4. We want to find out the interest rate, so it's wise to keep the interest rate on one side only. So let's do it. Let's actually leave the numbers on one side and the interest rate on the other side. So let's get rid of the 5,000 over here. How can we do it? We can divide both sides by 5,000 because it's an equation and we are allowed to do so. What we do on the left, we do on the right. Okay, so what's 9,000 divided by 5,000? Well, the zeros cancel out. So we only have 9 over 5 equals to 5,000 over 5,000 is just 1. So we're left with 1 plus I to the power of 4. Okay, we have 1 plus I to the power of 4, but then we would like to have only I. So how can we have only I on this side? Well, then we want to get rid of the power of 4 and only have the power of 1. Because it's an equation, we can play with some powers there. How would we do it? Well, we would take both sides to the power of 1 over 4. If we do so, look what happens. If we take this thing to the power 1 over 4 and the right side to the power 1 over 4, we will multiply these powers and 4 cancels out. So we would have 9 over 5 to the power of 1 over 4 equals to 1 plus I to the power of 4 times 1 over 4. And why do we actually multiply the powers? Well, remember from the simple power rule. Let's just write it over here to remember ourselves the power rule that we're using. We're using the following power rule, that if we have a base to a power and raised to another power, then we just multiply the powers. And in this case, this is our base, this is our a, this is our first power, and this is our second power. Okay, 4 times 1 over 4. Well, it cancels out. 4 and 4 goes away, and we're left with power of 1, which means that now we have 9 over 5 to the power of 1 over 4 equals to 1 plus I. And we are close to our final answer because now we have I on one side only. We could take 1 over here and subtract it because it's a positive 1. We take it to the other side, it becomes negative. So we have 9 over 5 to the power of 1 over 4 minus 1 equals to I. And if we plot that in our calculator, the result is equal to approximately 0.1583. And if we write it in percent, because that's more comfortable to understand it, well, 0.15, and if we multiply this with 100%, that's almost 15.83%, and that's it. That's the final answer.